क्या हो रहा है?
यूट्यूब निकल लिया।
अरे यार।
Hi guys, hi. Good evening, everyone. Yeah, so sorry we started a bit late. I don't know. This YouTube was behaving weird, so that's what it was showing something not available and all. So fine. This is not like right now. It is everything is fine, and we are here live, guys. And we are about to start day two of Master Data Structure Algorithm. So I welcome you all again to this day two. Hi everyone, good evening. Hi Vinayak, hi Jigar, hi Prathamesh, hi Ritu, hi Mehul, and everyone, Akash, Shiva, everyone. Good evening, one and all. So, guys, let's start this day two program of DSA. Let's not waste our time anymore, and let's start today's session. That is day two. Okay, so what we discussed in the previous session, we had discussed time complexity. We have had an in-depth discussion about time complexity, and we have seen so many examples like how exactly to uh, solve given a code, how to find time complexity, how to analyze a code, and all. We have seen that. So today we would see actually. Some bit of pointers, dynamic memory allocations, and also linked list. We'll start with that. So very important concept, guys. Linked list. I have seen so many of people are struggling with linked list. I've seen people they are good with like given a linked list and all. If anyone asks you to complete a function of insert or delete, they are like easily they are doing it. But when someone is asking to create a linked list and all, they are actually facing problems, lot of problems. So right here in this session we will tackle that problem. We would learn uh, creating a linked list end to end, guys, and we will learn it how to build a linked list, how to create a linked list from scratch, right? This what doubly and circular linked list cannot be touched, Jigar. I'm very sorry. I'm very sorry for that. I will not be able to touch that because of the obviously time constraint, obvious time constraint. So will not be able to touch that. But anyway, guys, I'll build your fundamentals in linked list in such a way that you can easily, uh, by your own, you can do that actually, circular and doubly linked list, right? Okay. So that's what guys, yep, I had posted assignment question in the community. I think I could not post it yesterday night, but I posted it today morning. So you can check it. Anyway, you have deadline, right? You have deadline. You can check it today, and you can do it, right? So let's see that. Let's see that. Yeah, Ritu, it is already there. Like you can check our channel, Let's Upgrade channel, and you will see faster data structure day one program there. Okay, in the playlist you can also check. Renisa, you have to check the community. It is posted in the community, guys. Okay, one more thing, guys. Also, like while we are learning this data structure, so it is just a bit of like we are doing this a small set of discussion we are doing, but there are a lot of things in DSA, right? So guys, also if you want to make career in any of the fields, like see guys, we have this postgraduate program, we have PGP full stack programs in four different fields like data science, AIML, Python, Django, and web development. So if anyone here want to make career and be expert in any of this field, we do provide a lot of PGP full stack programs. Do check out our website. Okay, maybe my teammates here can put here links of the respective courses. If you are interested, you can check it out, guys. So the price is 29,999. But if you guys, if you enroll for it within next 5 days, or for, yeah, next 5 days, you'll get a thousand, like 4,000 rupees instant discount on that. Okay, so you can apply for that. So let me also tell you what you will get in that. It's a 6 months long program where we will start like discussing in very scratch level from zero, and we'll go till hero level there, right? Okay, let's say you are talking about web development. It would contain HTML, CSS, React, MongoDB, Express, Node, also Vue, Next.js, everything. It's a complete whole package, full packaged course, guys. Not only the topic, core topic thing for your placements and all, we also providing other stuffs like data structure algorithm will be discussed in detail there, right? System design would be taught to you on in that. Also AWS cloud computing will be taught to you, because they are also related, required for your placements and all. Also you'll be uh, taught about how to prepare for placement. Mock interviews will happen, and mock screening test, mock recruitment exams that would happen. So all those things. Okay, so please uh, so piece of cake, what is there. So on the top of it, guys, also you will be able to sit for placement via Let's Upgrade. We are bringing in companies, you'll have recruitment drives, so we can also forward your like profiles, and you can get through companies and placement. You can have your dream job through Let's Upgrade by just enrolling into this PGP. All this stuff, guys, it's a completely live class, and you can go for doubt clearing session, everything as per your requirement. You just ask for it and it will be scheduled. Everything is there. 15 plus projects. Okay, one client side project is also there. So everything, all this thing for 25,999 if you apply in the next 5 days. Okay, but the original price is 29,999. We also do have EMI option, guys. You can pay back in EMIs, no cost EMI for 12 months. Yeah, Jigar. Yep, internships. I think will soon roll out also for that, those internships and all. Recently, we have closed an internship form. Actually, I'm not sure whether you get it, you got it or not, filled it or not. But yes, recently we have closed one internship form actually. So yeah, some or other day we come up with so many of internship and all. So yeah, that's it. That's it for this. Like about our PGP full stack programs. If you anyone of you interested in it, do check out our PGP programs. I think my friends have here from my team have put out your links for the PGPs. You can check out the curriculum and all those stuff. What you will get, everything is there. Fine. Let's focus. Let's now continue our discussion on master data structure and algorithm. This is day two. Let's start our discussion with pointers. Just give me a moment, guys. I'll be sharing a screen. Cybersecurity, as of now, we are not doing, Abhijit, but we are looking forward to do it in near future. Okay, I'm sharing a screen. Is it visible? Let me know. The whiteboard, I have shared whiteboard, the good old whiteboard where we were discussing yesterday about uh, the time complexities and all. Okay, I hope it is visible to you all. Okay, it is still initializing, guys. Yeah, so Where is the assignment? Assignment is posted in the community. Please do check out community. Also, guys, if you have not registered, please do register. Otherwise, you'll not get the benefit. You'll not be able to get certificates and all. Do register for it, because right now certificates are published on your profile in Let's Upgrade. When you log into Let's Upgrade, there is a certificate section. Okay, in your profile section, there's a certificate section. There, the certificates are available. So you need to register. Otherwise, you'll not get any benefit out of it. Okay, right? Every link, every possible link is there. Fine. Now, this is what we were discussing yesterday. I think this has been already done. So let me clear it out. Okay. Right now, we are discussing pointers. So I've seen many people are getting confused with pointers, but let's try to understand it at a very depth, a very basic level. Okay. So when I say int x, what is this, guys? Int x. What is this? What is this? Participation certificate is there in your profile. Even completion certificate would be there in the profile, but completion certificate would also be sent to your respective addresses. Okay, right? Yeah. So what is this int x? I've written here int x. So we say it is a variable, right? And we say this x is an integer variable, right? Okay, integer variable. So whenever we write int x, or whenever we write int x equal to 10, when it is compiled or something, a memory is allocated. Okay, so name of the memory location is x, and value there stored is 10. Okay, right? That's it. That is what happened. Whenever you write int x equal to 10, a memory is allocated, name of the memory location is x, and value stored there is 10. This is what happens. This is a integer variable. What is this? When I write this int star p, what is this? So x there is an integer variable. What is p here? Community, Jay, there is no tab, there is a link for community. Int x equal to 10, x here is an integer variable. Int star p, then what is p? Who can say? What is p? What is p? X is integer variable. Similarly, what is p? So p here, basically, guys, p is a pointer variable. Yes, exactly. You are correct. Okay, it's a pointer variable. So it is also a variable. The thing is, it is a pointer variable. Okay. So we say x is an integer variable, right? So p is also pointer variable. How many of you are saying it is a integer pointer? How many of you are saying integer pointer? If you are saying integer pointer, then you are wrong. You should not call it as integer pointer, guys. Always read this in this way. See, p is a pointer to integer. This is the way in which you should read. Okay, p is the pointer to integer. P is a pointer to integer. P is also a variable just like x, but it is a pointer variable. It is pointer to integer. X there stores some integer value, but p here is supposed to hold address of an integer variable. Okay, right? Because p is a pointer to integer, so p is supposed to hold address of an integer variable. We do have an integer variable here, that is x. So I can store here address of x in p. So I can store address of x in p. Ampersand x, it will give me address of x that is being stored in p. So guys, it's very much similar to the concept of variable, whatever we know already. Whenever this line is compiled or something, a memory is allocated. Name of the memory location is p. Okay, and when you store address of x will be stored here. Let's say address of x is 101. For an example, let's say address of x is 101, the address of the memory location whose name is x. Let's say address is 101. So that 101 is stored in p, and we say that p is pointing to x. So for p, address of x is the value, but for x some integer value. we can store directly. Okay, so p here is a pointer to integer where I can hold address of an integer variable. So this is what happens here, guys. When I have an integer variable x, let's say address, let's assume it to be 101. It's not exactly 101. It would be something different. But right now we are assuming address is 101. So p will hold address of x here. By this statement, we are storing address of x in p. So 101, and we say that p is pointing to x. This is the whole concept of pointer. Okay, this is how we create a pointer. This is how pointer points to an integer variable here. Okay, so this is a p is a pointer to integer. Similarly, if I write char star s, then you read s is a pointer to character. So s will hold address of a character variable in that way. Okay, this works in this way, guys. So now the question is, if I write C out X, I'll get obviously 10. This we know already. Now the question is, if I write C out P, what I'll get? Say me, guys. If I write here C out P, what will I get? What I'll get here? C out X gives us 10, the value of X. If I write C out P, what will I get? What would be the value printed? Say me, someone put in the chat, put in the comment, guys. Put in the comment. Address of P. Jigar says address of P. What about others? What value would be printed when I print C out P? Yes, exactly. It would be 101. Correct. For X, the value is 10, but for P, the value is 101, which happens to be address of X. Right? Plain and simple. Now, if you want to print 10 using P, then you have to write C out star P. This will give you 10. Star P means value at P. What is P, guys? P is 101. Star P means star of 101. Okay? P is 101. So star of 101. Value stored at memory location 101. That is 10. So this will give you 10. That's how it works. Star P value at the memory location 101 or value at the address 101. Okay, so this is how you access value through pointer. Now here, if you print C out ampersand x, it is quite very clear. It will give you address of x, that is 101, same. And if you print ampersand of p, you'll get address of p, guys, because there is also a memory allocated for p. It will also have some address, so you will get that address of p, because it is also a variable. P is also a variable, just like any other variable. P is also a variable, so memory is allocated for p too, and it also have an address associated with it, right? Okay. Amritanshu, you can use pointers, a very simple application, and like the most commonly used application of pointer is for dynamic memory allocation. To create memory dynamically, pointers is required. Without pointer, you will not be able to create, you will not be able to allocate memory dynamically in C. Okay. Also, even in C++, the same thing. Same thing goes. But say in C++, we also have the concept of class and object, so you can also use class and object for dynamic memory allocation. But here, like in C, you don't have class and object, so only thing happens. So we can go for pointer. Okay, one more application is point through pointer. If we access values, it would be faster operation, because it is actually you are directly accessing the memory location. Okay, you don't have to decode something, you don't have to fetch the memory location address and all. So while you use pointer to access any value, you are directly accessing the memory location, so the operation should be faster actually. Okay, so now, okay, this linked list and all, they are all like using pointers we create. Okay, using pointers only it is possible to create linked list and all. Even trees, graphs. Okay, graphs and trees we can also use arrays. But trees, guys, let me tell you, trees, for trees we normally prefer linked list. Okay, again, for linked list we need pointer. So that's a vast application of pointers. It's not like there's no application of pointer. Pointer is very important, but yet so many of people like struggle in pointers. It's a building block. First, if you don't understand pointer, then you cannot understand dynamic memory allocation. And if you don't understand dynamic memory allocation, you cannot understand linked list. If you don't understand linked list, you cannot understand tree application, like tree operations and all. It's all related. It's all linked up. Okay. Address is address of any variable. Pointer is someone who stores that address. Pointer is a variable, basically pointer variable. Okay, fine. I hope you have now a good understanding of what pointers does here. Pointers basically stores address of a variable, and we also now know how to access value using pointer. Like star p will give us the value located at that value. If I write cout p, it will just give me address of that memory location. And when I print ampersand of p, it will give me address of p. It's a whole thing. Okay, about pointer. Just type it and submit, Jai. Okay, now, so this part is done. Now, if you have understood, I hope you have understood, guys. Okay, so what we did here, like int x equal to 10, right? So memory location is allocated, name of the memory location is x. Let's say address of that memory location is 101, so value 10 is stored there. Now I have one more pointer p which is holding address of x. So what will happen first? First, a memory location is created, allocated. Name of it is P. Obviously, it is also associated, some address is associated with this memory location. So let's say it is 201 and P is a pointer. So pointer to integer and it is holding address of X. Address of X is 101. So 101 is stored in P. We say that P is pointing to X. This is what we have discussed up to this point. Okay, right. So what is ampersand n or ampersand x? Ampersand x, it is basically give you address of, ampersand n will give you address of n, ampersand p will give you address of p, ampersand x will give you address of x. That's it. Okay, now, so similarly, guys, see, this is p is a pointer to integer, right? It stores address of integer. Now if I write this int star star, let's say q, what is this? Who can say? Two stars I have put. Int star star q. What is this? Who will say here? Who can say? Int star star q. Int star p, we know p is a pointer to integer. What is this, guys? Int star star q. I think there is a like bit more lag today. That's why whatever I am saying right now, it is being telecasted in a delayed time. Q is the pointer to the pointer to integer. Yeah, exactly. Yes, Jigar, it's correct. Yep. So you read in this way, guys. Q is a pointer which is pointing to another pointer which is pointing to integer. Q is a pointer to a pointer which is pointing to integer. So you can just say Q is a pointer to pointer. So Q is a pointer variable which is pointing to another pointer to integer. Okay, right? So Q is supposed to hold address of a pointer, and here that pointer should be pointing to an integer. So we already have a pointer to integer, that is p. So I can store address of p in q. You can say this is a level 2 pointer or double pointer also we normally call it as. Okay. So in q I can store address of another pointer to integer. Here I have a pointer to integer p. So I can store address of p in q. Q can hold address of pointer to integer. Okay, so in q I can store address of p. So what will happen here? Same thing, guys. Whenever this statement is read, a memory location would be allocated. Name of the memory location is q. It is also associated with some memory address. So that let's say this is, let's assume 301, and you are storing an address of p in q. Address of p is 201. So you store value of q is 201. So we say q is pointing to p. It's a level 2 pointer or double pointer also we say. Okay, right? So now if I print q, so this will give me value of q, that is nothing but 201. Whatever value stored in q, that is what I'll get. Okay, so if I now print ampersand of q, it will give me address of q. Address of q is nothing but 301, right? Okay, and again, if I write cout star q, what is star q, guys? Star q is nothing but star of 201, because q is 201, so star q means star of 201, value stored at memory location 201. What is the value stored at memory location 201? It is 101. So you will get here 101, right? And then if you write star star q, what you will get? So star q is basically 101, right? We just got it. So it is star of 101. Value stored at memory location 101. What is the value stored at memory location 101? 10. So you will get 10. Basically, this is how you access value, an integer value, or some value through double pointer by putting double star. Okay, this is how it works, guys. Okay, I hope you have now a clear understanding how pointer and this double pointer work. Similarly, you can go on, like you can write in star 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 q, 3 stars, but we don't need it. We normally won't need more than this double pointers. Up to this we will need, but I hope up to this it is very much clear how pointer is working and how to basically access value by using pointer. That is the most important part here. Is it clear up to this, guys? Please let me know in the comment so that I'll move ahead. Now we know how to create pointer. We know how to store address in pointer. Now we know how to access value using pointer. Three things we have discussed. Is it clear up to this? I have a question next. If you confirm you are clear on this, I have a question for you. We'll discuss that out. Okay. Crystal clear. Okay, great. Thanks for the confirmation. So let me clear this out. I have a quick question for you guys. Let's see who all can answer. If you have understood pointer, you should be able to answer this question. So I have this I equal to 0, j equal to 0, right? I have two pointers, int star p equal to ampersand I and star q equal to ampersand j. Okay, so p equal to q, star p equal to 2, then C out I and J. What would be the output of this? I just need the output here. That's what. What would be the output? Aman, ampersand of Q. Yes, ampersand of Q would be 301 because address of Q. Yeah, Jishan, star Q will give you value at 301. Value at 301. What is the value stored at 301? 201. So you'll get 201 in that. Whatever value is stored in Q, that is what you'll get. Yeah, just give me the output, guys. Here for I and J. So int I equal to 0, j equal to 0, n star p equal to ampersand of I, star q equal to ampersand of j, p equal to q, star p equal to 2, and then I'm printing value of I and j. Let me know what would be the output here for this question. It's a good question, simple question, yet I've seen people making mistake here. It would give two outputs, right? Value of I and value of j. So what is that? Okay, Shiva says 0, 2. Prakash, okay, Prakash has given only one output. It should give two. Okay, PK Seva Gaming 0, 2. Aman says 0, 2. Hemant says 0, 2. So let's see for ourselves whether it would be 0, 2 or 0, 0. Like Shreyas has mentioned 0, 0. Hemant says it would be unchanged. Let's see it. So first of all, let's create I and j. So this is I and this is j. Let's put some dummy addresses 101 and 201. I is 0, j is 0. Okay, right? Then create the pointers p and q. So p is holding address of I. Basically, p is pointing to I, and q is holding address of j. Q is holding 201. Now I'm writing here p equal to q. So you are storing the value. You are storing the value of q in p. What is q? Q is 201, and you are storing in p. So p value is now 201. That means p is not pointing to I anymore. Rather, p is pointing to j because it is now holding 201. Okay, right? And then you are storing star p equal to 2. You're storing 2 in the memory location pointed by p. Okay, star p equal to 2. That means at 101 memory location, sorry, at 201 memory location, p is now 201, right? At 201 you are storing 2, so this would be updated to 2. When you now print I and j value, you'll get 0 and 2. That is the answer. I see like so many of you have given correct answer at 0 2. Those who have given 0 0, please correct it, guys. Please understand it would be 0 2. Okay. Yeah, J has two pointers pointing to it. Yep, exactly. Both P and Q are now pointing to J and not I anymore. So output would be 0 and 2. That's it. Simple. Okay. Clear? Is this clear, guys? Is this thing clear? I hope it is clearly visible. Nikhil, I don't see any problem. Like, even I am watching the YouTube beside. It is like for me, it is like clearly visible whatever I'm writing. Maybe you should check your video quality setting at which you are watching right now because it is clearly visible. Even at 360 for me, I can read it, whatever I'm writing, and also I'm speaking continuously. So now, okay. Now let's move on to the next question. So I hope everyone understood with this problem. We understood again the usage of not usage basically how pointers work. Next question. Let's say I have int star p, char star s, float star f. Okay, right. Then I have let's say I have a structure, guys. Struct student. I have this int roll number, and I have this let's say float marks. This is the structure. So I am here creating a pointer to structure S. Okay. My question to you is, if I print size of P, size of F, size of S, size of, okay, I should change it to ST. Okay, right? So size of S, size of F, and size of st. I hope you know what is size of. Size of will just give me the size of the total memory occupied by these variables, right? So what would be the uh, what would be the size basically? What would be the output here? If I print size of this p, s, f, and st, what would be the output, respective outputs? Can you give me the output of this four thing? What amount of size? Okay, Jigar is saying some answer. Hemant says same as a data type. That means Hemant says P would be 4, S would be 1, F would be 4, ST would be, as per you, it would be 8 bytes. Right, 4 for this, 4 for this. Total 8 bytes. Right, this is what we're saying. Okay, yeah. I think like most of you are giving the correct answer, guys. Every output would be same here. For all these things, output would be same. It won't change because all of them are pointers, and pointer is supposed to hold address, and address is of fixed size. Okay, address may be of anything, but address is of fixed size. So what is this actually when we are saying 32-bit system or 64-bit system? 64-bit system means you have 2 to the power 64 addresses possible, and the address to store an address you need 64 bits. Similarly, when I say 32-bit system, Actually, there are 2 to the power. That means 2 to the power 32 addresses are possible, and 32 bits are required to store an address. Okay, so whenever you create a pointer, as pointer is supposed to hold address, it depends on the system, guys. If you're using 64-bit system, then 64 bits would be allocated, and that is 8 bytes. And let's focus on 64-bit, because right now almost all the systems are 64-bit. So you'll get output as 8 bytes for all of them. There would be, it would not be like 1, 2, 4 different for different kind of this. No, it doesn't depend on data type. Yes, exactly, Krati. Okay, it doesn't depend on data type. Pointer is supposed to hold address. It all depends on the size of the address. So 64 bits would be allocated for everyone. That is 8 bytes for everyone would be allocated. Whatever that pointer may be to integer, pointer may be to character, pointer may be to float, pointer may be to double, pointer may be to a structure containing hundred of members. Still, it has to just store an address. Address is a fixed size, that is 64 bits or 8 bytes. If you are talking about a 64-bit system, okay, right? Clear this part, everyone? I hope it's clear. Let me know on the comments, guys. Let me know in the comments. Is it clear to you all, everyone? If it is clear to you, this part, this comes usually in the recruitment, right? Like in some MCQ questions, they try to give you some tricky question, and they ask you, okay, what would be the size? They will give you all option, and there will be some option like 8888. So you just have to either 4444 or 8888 would be there. You just have to select that. 444 means they are talking about 32-bit system. Fine. So this is one more good and important question which I had to discuss on pointers actually. So size is fixed for any kind of pointer. It depends on the what kind of system you're using, what architecture is a 64-bit or 32-bit. That's it. Okay. Now we know pointers concept, guys. We are pretty much clear with pointers. Now let us what we do right now is let's delve into this dynamic memory allocation. Okay, let's talk about dynamic memory allocation, or in short, DMA, dynamic memory allocation. So, who can say what is DMA? What is dynamic memory allocation? So, the memory which is allocated at compile time, it is known as compile time allocation or static memory allocation. Right? When I write this int x, whenever the statement is compiled, at that moment of time, memory is allocated for x. Okay, this is called as static memory allocation. Okay, if memory is allocated during compilation of a code or statement or a program, that is known as static memory allocation. Whenever memory is allocated at runtime while the program is executing, then that would be known as dynamic memory allocation. Okay. Rohit, no, will not do that. We'll talk about that. I'll come to that, Rohit. Before starting linked list, we'll discuss on that, Rohit. Don't worry about it. Okay, guys. So if memory is allocated at compile time, it is known as compile time memory allocation or static memory allocation. If the memory is allocated at runtime or during execution of the program, that is known as dynamic memory allocation. Okay, right? So some examples of dynamic. Okay, if you talk about arrays, arrays is static. Arrays are static. Once you have created, guys, you cannot actually increase the memory. Okay, increase the memory, increase the size. If you have created an array, let's say this is how we create array, right? Int arr of 10. So what will this do? This will allocate our 10 blocks of adjacent memory locations, right? Okay, and it is fixed. You cannot change the size again. You can only store 10 element. You cannot store more than 10 elements. Also, even if you have only 3 element, let's say 3, 4 and 5, rest of the blocks would remain vacant. You cannot also decrease the size. So once you create array, it is fixed, it is static. Okay, it is static. You cannot increase or decrease the memory size. That's why Array is static, guys, and this is a problem with arrays. That's why we look for linked list. That's why we look for linked list, because linked list is dynamic. Whenever we require, we can increase the size, the capacity, the not capacity, we increase the size of the linked list. We can, whenever we need, we can add more element. Whenever we need, we can delete elements. Okay. Here in array, even if you delete some element, but the memory is still be occupied, it would be there because it is static. Okay, it is static. Array is static. You cannot change the size, the memory. It is fixed. Once you create it, it is fixed. Linked list is dynamic. Okay, because you, whenever you need, you can add a node. Okay, whenever you need, you can delete a node, right? And that, because that is possible because linked list is dynamic, and all these things are possible because of dynamic memory allocation, guys. If there is no dynamic memory allocation, then even linked list cannot be dynamic. It is possible because of dynamic memory allocation only, and for dynamic memory allocation we will need pointer. So it's all related. Okay, it's all related. Yeah, man, exactly. Memory, not exactly memory loss. I'll just say efficient use of memory is not done in static memory allocation. That's why we go for dynamic memory allocation. We can increase whenever we need, we can decrease whenever we need. That's a flexibility there, which is not there in static case. So that's why we go for linked list over array. We prefer linked list over array for this particular case. Okay, and this is possible because of dynamic memory allocation. So what is dynamic memory allocation? If memory is allocated at runtime or during execution of the program, that is called as dynamic memory allocation. If memory is allocated at compile time, like this int-x and all, okay, this int-x, then memory is allocated at compilation, during compilation. That is called static memory allocation or compile time memory allocation. This is about uh, dynamic memory allocation, guys. Okay, there's a comparison between this static memory allocation and dynamic memory allocation. Also, we discussed why linked list is preferred over array, because array is static, we cannot really change its size. But dynamic, this linked list is flexible, we can increase or decrease the size whenever we need, because of it's all possible because of dynamic memory allocation. Okay, Naseem, I repeat, please do check community for assignment. It is posted there. You have to see there. You have to check there. Yeah, yes, vector Rakshit, yes, vector dynamic. Yep. But you are talking about the STL libraries of C++. Yes, they are dynamic. Fine. Now let's see how exactly we would allocate memory dynamically, or how, let's see how exactly we'll allocate memory at runtime, how we will use pointer, how we will allocate memory at runtime. Because we know, when I write in text, this will create memory at compile time, it will not create memory at runtime. So how to create memory at runtime, how to use pointers, and let's see, let's understand how to create memory dynamically at runtime. Harika, there is a link, so assignment submission form link there. Just after the session, you just check that link. Okay, there it would open a form. Also, there is a video embedded over it. It has been guided. Everything has been guided how to submit assignment and all. Okay, fine. So, yep, let's now understand how to actually do dynamic memory allocation. So, guys, to know or to create memory at runtime, there are some functions you need to be aware of. Okay, like malloc or malloc, memory alloc, I'll say. Then there is calloc or calloc. Then there is realloc. Then there is free. So these are some like four functions which you should be aware of while dealing with dynamic memory allocation. Okay, this malloc and calloc or calloc, they actually allocate, they create memory dynamically. Okay, right? Malloc and calloc, they create memory dynamically. These two functions are used to allocate memory dynamically. How to create, let's see what is the syntax of malloc. So see this, malloc is actually this void star malloc, and here we would the size of memory you want to allocate, it will take this. Okay, similarly calloc is this void star calloc. C is small, guys, even M is small. Here you will like pass two argument, the number of blocks and size of each block. These two things it will take, this calloc and malloc. So both of them are used to allocate memory. Okay, both of them are used to allocate memory dynamically at runtime, guys, both malloc and calloc. But malloc is preferred over calloc. Malloc is preferred over calloc because malloc is faster. It is faster. Malloc is faster in compared to calloc. Okay, so malloc is faster compared to calloc. The difference between calloc and malloc is, first of all, it takes one argument, malloc takes one argument, and calloc takes two argument, right? Okay, first difference. Second difference is malloc is faster than calloc. Third is calloc allocates a memory and assigns a initial value, okay, with 0. But malloc doesn't assign any value, it just allocates a memory. So it will contain some garbage value, we don't know, some random value it would store. But calloc, what it does, it allocates memory and assigns that memory. It stores a default initial value 0. That's a difference. But yes, yet again, calloc is slower compared to malloc. That's why we prefer malloc. Also, while creating memory, we normally don't need any default initial value, so we are good to have garbage value, we later change it. So we go for malloc. Okay, right? Yes, Jigar, you are correct. In C++, we do have other options like new and delete. Okay, these are operators and not functions. New, by using new you can allocate memory, dynamic memory, okay, at runtime. And delete deletes the memory. What memory? The memory which has been allocated dynamically, that memory you can delete using this delete operator. In C++, you can use this new delete or malloc alloc, not an issue, guys. Okay, whatever you can use in C, all those stuff you can also use in C++. C++ is just an extension of C. So whatever you are doing in C, that can be used in C++. So malloc and calloc, malloc, calloc, realloc, free, everything is there in C++. But yes, in C++, you also have a way, this new and delete. I'll also tell you guys how to use new and delete to create memory, okay, and delete memory. I'll tell you. Don't worry about it. Let's first understand how to use malloc. Okay, we'll not see calloc because malloc is preferred. Malloc is faster compared to calloc, and popularly malloc is used to allocate memory. Let's see how to allocate memory using malloc. Okay, fine. Let's see how to. I want a memory to store an integer. Okay, right? I just want a memory to store an integer. I want to allocate a memory to store an integer variable. How to do that? First of all, you need, okay, you need a pointer variable. Pointer is used. Pointer is required, necessary to in order to create dynamic memory allocation guide. So first of all, you create a pointer to integer, right? Next, you can call this malloc. Actually, you can call malloc. Just pass the number of byte you want to allocate. How many? What is the amount of memory in one integer variable takes? 4 byte, right? You can write here directly 4, but let's not make mistake. System to system, if you talk about 32-bit system, it will take 2 byte. But if you are in 64-bit system, it will take 4 byte. So why to worry about system and all? Just put here size of int. As per the system, it will calculate automatically whatever is the size of integer. It will allocate a memory of that much size. If size of integer is let's say um, what is that, 4 byte, it will allocate a memory of 4 byte. That's it. If it's 2 byte, it will allocate a memory of 2 byte. Okay, so malloc here will create malloc here will create a memory dynamic at runtime. Okay, which is like the memory which can store an integer of size 4 byte. Let's say address of it is 201, for example. Okay, when you have written int star p, so a memory location, this is very important, guys, please focus here. This is very much important. This is where most of the people make mistake. Please understand this. Your linked list is nothing, guys. If you understand pointers very well and dynamic memory allocation very well, then linked list is just a playground of pointers and dynamic memory allocation, nothing else. It would be a piece of cake for you. Okay, let's see this. So when you write int star p, a memory location is created for p as it was being done at compile time, static memory allocation for p. Maybe it will have some address 101. Okay, what malloc will do is malloc will create a dynamically like it will allocate a memory, create a memory, allocate a memory at runtime. Maybe address of that memory is 201, and malloc will return that address of that memory location allocated. That means here p will hold that 201, and we say p is pointing to that memory which has been allocated dynamically. This is very much important. This is what you need to understand here. Okay, no jigger attendance is also for your participation certificate. It is also for feedback. It is also for your participation certificate. Okay, so if you have not registered, you do have to register. Fine. Yeah, that's what we were discussing here. Uh, yeah, so that's what we're discussing. See, guys, whenever this p in star p you write, a memory location of p or for p is created. Memory location for p is allocated. It will have some address, let's say 101, and this malloc will allocate a memory at runtime. Let's say address of that is 201, and address of that memory is being returned to p. P is holding address of that memory allocated dynamically. So p is actually pointing to that dynamically allocated memory. Okay, right? No, not at all. Jishan, no. Obviously, it cannot. Data structure, how it is possible to cover everything in these 3 days of data structural concepts? No, obviously not. You should understand this. Not complete every concept. Okay, but whatever is being done, it will definitely clear your concept. Linked list, your concept will be very much clear. Pointers concept will be very much clear. Dynamic memory allocation concept will be very much clear. Okay, right? Whatever we are doing, at least you can be pro in that part. Okay, please do. I think you have to create a account, Jigar. I think have not. You don't have any account in LetsUpgrade. You just have to create an account there. Okay, so this is what we are doing here. This is what we are doing here, guys. Okay, so malloc will allocate a memory dynamically and will return address of that memory, which would be stored in p. So p is a pointer now which is pointing to that memory which has been allocated dynamically. And one more thing I want to point out here, I have left some space here for a specific reason here. Okay, need to fill it here something. Okay, remember, guys, if you remember the syntax of malloc, it was void star malloc and some size. Okay, so by default, the return type of malloc is void star. I'll talk about void star what it is, but right now let's focus on here. Let's try to understand things. So malloc returns a void star type of, it returns void star, but p is a pointer to integer, and I actually tried to create a memory for an integer. So you need to typecast that void star type into int star. Okay, So you should say, yep, the malloc should return pointer to an integer, not pointer to void. I'll talk about void. Okay, I'll talk about this void, guys. Don't worry about it. I'll talk about this void star. But right now, just understand malloc will create a memory. It will allocate a memory dynamically, and it returns an address. It returns address of that memory, right? But if you see the return type of malloc, it is void star. So basically, it is returning a void star kind of value. But what is the type of p? Type of p is int star. Okay, p is a pointer to integer. So you have to typecast that void star into int star so that everything will go hand in hand. It would be uh, typecast means you have to convert void star into int star. This is typecast operator, guys. You put parenthesis inside it. You put int star. So you are converting the void star type into int star. This is the complete thing. Okay, so whenever you want to allocate memory for an integer, for one integer, you have to write int star p equal to int star malloc size of int. Whenever you want to create memory for let's say you want to create memory for character dynamically, you have to write char star s equal to char star malloc size of char. This is what you have to do. Understood, guys? How we use malloc to create one memory of integer, how dynamic memory is allocated, what is the syntax to dynamically allocate memory. Is it clear to all of you? Yes, Padmini, it is there in the community. It has been posted. Is it clear, guys? Is it clear? Yeah, that's what I have written, Aman. Okay. On one line, I have written int star p equal to int star malloc size of int. Okay, right. So is it clear, guys, how to dynamically allocate a memory for one integer or how to dynamically allocate memory for one character? You better if you upload in like document format, type it. Clear? Yep, it is clear. So why we are writing here int star and why we are writing here char star, guys? Why we are writing int star? Why we are writing char star? Because the default return type of malloc is void star, but on the left hand side it is like int star p, and here it is char star s. So it should be equal. The type of, okay, right? Whatever malloc is returning, type of that should match with type of this p and s, right? LHS, type of LHS and type of RHS should be equal. That's what we are doing here. So we are typecasting void star as per required. If I want to create memory for integer, I'm converting into int star. If I want to create memory for character, I'm writing here char star. I'm converting it into char star. That's it. That's the whole thing we are doing here. Nothing else. Okay, right? So this is your this is how you create memory for integer. How to use new operator to create memory for one integer? It's simple. Just write int star p equal to new int. That's it. Okay, that's it. So basically, it would happen the same thing. Basically, this is what will happen. A memory would be allocated, dynamically allocated, and its address would be returned to p. P would point to that. Okay, right? So okay, I would come to this void star, guys. I'll have a detailed discussion on this void star, also some other stuff. But let's at the time being for the time being, let's understand this dynamic memory allocation in bit detail. That's what will make difference while you go into linked list actually. So right now I'm cleaning it up entirely. So I'll rewrite the code whatever I had written there. That is, I want to create memory in star p. I want to create a memory for one integer. So I'll write here in star p in star malloc size of int, or I can write int star p equal to new int. That's what I need to do. Okay, right? See, same thing I'll be explaining here, but I'll be adding some more concept here. Basically, I'll be talking about the same thing, but I will add some more concept here so that it would be more clear and we would get more information. Okay, right? See this. There are different memory areas, guys. Okay, I think you might have heard about different memory areas. Like some memory area is dedicated for the operating system solely. Okay, something called BSS memory area. Then there is text segment, text area, where the instructions are stored. Then there is stack memory area. Then there is heap memory area. Right? Okay, this is of what we have. Okay, right? Text area. I think I left out one more area here. That is, give me a moment. Why it is getting stuck? My system is getting stuck a bit. Fine. Now it is fine. Yeah. So there are different memory areas. Memory has been divided, actually, has been assigned. There are designated memory areas, guys. Some memory area is designated for only operating system space. Something for BSS. Okay. Something for data segment. Okay, then there is text area where the instructions are stored, the code actually. Then there is the stack memory area, and there is this heap memory area. These are the different memory areas available in our system actually. Okay, I want to focus here on these two memory areas, heap and stack. This stack, guys, in stack memory area, all the local variables, the memories for local variables or intermediate results, okay, function informations, okay, information, the details, function addresses and all, they are stored in stack. This heap is entirely designated for dynamic memory allocation. Whatever memory would be allocated at runtime at dynamic memory allocation, that is actually created in heap memory area. So, guys, whenever write this statement or this statement, okay, so this is stack memory area, right? This is stack, and let's say this is heap memory area. See, guys, this is where everything becomes different here. In stack memory area, memory for P is created because memory for P is allocated at compile time. It is a local variable. Okay, it's a local variable, guys. Got it? It's a local variable. You might think this. Let's say we are in a function, some function void fun, and inside that function we have written this statement, right? So p is a local variable. It is created inside this function fun. So memory for p is allocated in stack memory area. Maybe its address is 101, let's say. But whatever memory that would be created by malloc or this new int, that is dynamic memory allocation, that is being created at runtime. So that would be allocated in heap memory area. Okay, understood? That would be allocated in heap memory area. Maybe address of that is 201. And as we know already, malloc will return address of the that memory to P. Okay, so 201 would be stored here. P will hold 201 and P is referring to that memory location. So actually here, guys, two memory areas are involved here. Two memory areas, guys. For the deadline and all, please also have a look on the community. It is all posted there. What is the deadline? Even I think you have added the date sheet in your calendar. Even there it is mentioned. Also, Josna has mentioned here. That's what your deadline is. Okay, it should match. Majorly, you should follow whatever is mentioned in your community. Okay, whatever mentioned in your community, that is the final one. That is the deadline. Fine. Now, this is what happens. Stack memory area, heap memory area. There's a difference. So two memory areas are involved whenever you are working on dynamic memory allocation. The point memory for the pointer is allocated in stack memory area. The memory which you actually the memory which is allocated by malloc or new is created in heap memory area. And guys, that dynamically allocated memory do not have a name. It is an unnamed memory location. The pointer is the only reference to that memory location. Is this point clear? Tell me. If you don't understand this, then you would face problem while dealing with linked list, guys. Please let me know if this is clear. Is this clear? So two memory areas are involved. P is created in stack memory area, that memory which has been allocated by this malloc or new, that has been created in heap memory area, and P is the only reference to that memory area. Okay, right? We don't have any name for this. The only way to access this memory area is through P and nothing else. That's it. That's the whole thing here. You have to understand. Okay. Now, see this. I want to erase this part. Now we are going into depth, guys, of this dynamic memory allocation. We are discussing about some important concept which they ask normally in the interviews. Yep. Let's see. So now I'll also erase one of this. Maybe I will erase this malloc, or maybe I'll erase this new int. Let's erase this new int part. Anyway, both of them will do the same thing for us. It will allocate memory, and we know the syntax now. See, guys, we've allocated memory and all. Maybe we will store some value there. Star p equal to 20, let's say. So this in this memory we are storing 20. We are accessing that memory location. Maybe we'll do some more operation. Now, let's say we are done with the function. We're done with the function. Function is done. We are coming out of the function. So we are now out of the function. When you are out of the function, when the function is finished, this p being a local variable would get automatically deleted. That is what we know already. Local variables get deleted automatically as soon as you go out of the scope of the block where it is created. So as soon as you come out of this function fun, this p will get deleted automatically, right? This will get deleted automatically. So when it is deleted automatically, guys, you also lose reference, the only reference to this dynamically allocated memory. So the characteristic of static memory is it will be deleted automatically when you go out of the scope of the block where it is created. But the memory which has been allocated dynamically, that doesn't get deleted automatically. That will be deleted only when the entire program is over. Okay, let's say you are out of this function fun, and you are now in you have returned to main function. So now main function, the rest of the statements are getting executed. This memory would still be there. It won't be deleted. Also, it is holding some value and you are not able to access it. That would be the case here. Understood what situation I'm trying to say here? When you are out of this function fun, you'll return back to main function, right? Okay, maybe main function, maybe some other function, fine. So you are out. The thing is, you are out of this function fun. When you are out of this function fun, p being a local variable of this function fun would be deleted automatically. But the dynamically allocated memory, that would not get deleted automatically till your program ends. It would still be there. It will hold some value, but you cannot access it anymore because the only reference was p and it has been deleted. So we cannot access that dynamically allocated memory anymore. Got it? Okay, understood the situation. The memory is still, the dynamically allocated memory is still there. It is holding some value, but you cannot access it anymore because you have lost the reference. That pointer has been deleted. What is the situation, guys? Who can say? It's a very important and most commonly asked interview question. What is this? What is the situation called as? Who can say? Let's see. They would not give you the situation and ask you what is this. They will come other way around. They will give you the name and will ask you to explain the situation. But here I have like gone into a reverse manner. I've explained the situation and I'm asking you what is the situation called as. Okay, guys, let's not waste more time. I'll tell you. This is memory leak. You might have heard this. This is memory leak. So, what is memory leak? Memory leak happens when uh, the when you have lost the only reference to the dynamically allocated memory. The dynamic memory allocated memory is still holding some value, and you are not able to access it. This is known as memory leak. Okay, this is known as memory leak. So basically, what we should do is to avoid memory leak, guys. It is actually user problem. This is problem user, mistake of user. What users should do is actually users should, before going out of this function, user should free that dynamically allocated memory. You can write free p. When you write free p, this memory would be deallocated first. Okay, then when you will come out of this function fun, this p would be deleted automatically. This should be done in order to avoid memory leak. So when user forgets to free the dynamically allocated memory and come out of the block, then memory leak happens. So it is user's fault actually. Users need to take care. User needs to take care about this. Okay, right? So what is memory leak, guys? Memory leak is nothing but when user forgets to free the dynamically allocated memory before going out of the block of the scope where the pointer is created. So what happens? You lose the only reference to the dynamically allocated memory, right? Now, so dynamically allocated memory is still there. It is holding some value, but you cannot access it anymore. That is known as memory leak. Why it is created? Why it occurs? Because user forgets to free the pointer, right? Okay, that's where the problem is. So user should free the dynamically allocated memory before going out of the scope of the block where the pointer is created to that dynamically allocated memory. Understood? I hope it is clear. Question would be like, what is memory leak? Can you explain me what memory leak? Can you explain the situation memory leak? So you can just draw this thing, two thing, and make the interviewer understand. Just you just explain yourself. Okay, this is memory leak, and yep, that would be done. Clear, guys? Memory leak. Let's now come other way around. Okay, right? This is P. This is the memory allocated dynamically. Address is 101. Maybe its address is 201. So 201 is there. And we say P is pointing here. So 20 is stored here. That's it. Now memory leak we understood. Let's now, yeah, that's what I have written, Dishan. Just use a free function. Free, and within the argument you pass p, or you can write, if you have created using new, you can write delete p. Okay, if you have used if you have allocated memory using new operator, then you write delete p. If you have created or allocated memory using malloc or calloc, then you use free. That's it. Now let's come to a different situation here. Memory leak we understood. Okay, memory leak we understood. Now it's a different case. See this, guys. Now we have this. Now we have freed this p. Okay. Now we have freed this p. So when we write free p, this memory would be deallocated. Deallocated means it will not be allocated to you anymore. It is freed. It is added to the free pool of heap memory area. Now it will also not store 20. It will hold some garbage. Okay. Let's say this is the heap memory area. Somewhere maybe this memory was allocated to you holding 20. Now this memory is not allocated to you. Okay, right? This is not allocated. It is not holding any more to 20 or something. It is holding some garbage value. Memory location would still be there. Where the memory location would go, it is a memory, like it is an architecture. So the memory is there, but it is not allocated to you anymore. It is deallocated. It is not holding any value. It is added to the free pool. It is treated as a free memory now. Okay, right? So it can be reallocated again later someone for someone. Now see this, guys. Now after freeing it up, if I now try to print cout star p, okay, if I now print cout star p, what will happen? See, P is already pointing, still pointing to 201 because the memory location 201 is not gone. Like it is not gone anywhere. It is still there in the free pool of heap. So P is still pointing to the memory location 201, but it has not been allocated. It is deallocated. It is not holding any value. You should not access it actually. Technically, you should not access it anymore. But when you write cout star P, it will give you some garbage value, not 20, because it has been deallocated. What is the scenario called as this situation? When P is pointing to a memory location which has been deallocated already. When you are trying to access a memory location which has been already deallocated and P is still pointing to it. Yes, Akash, you are correct. It is dangling pointer. This is dangling pointer. You can say this is a reverse situation of memory leak actually, but this is a dangling pointer. This is called as dangling pointer. These are not types of pointer, guys. These are just situations, some error kind of situation you can say. Okay, right? That was memory leak. This is dangling pointer. If P is still pointing to a memory location which has already been deallocated, and you are trying to access that memory location now, that would be called as dangling pointer. So this question normally they ask, guys, what is memory leak? Explain memory leak. Explain dangling pointer, explain wild pointer, explain null pointer, right? Okay, so I hope everyone is clear with memory leak and dangling pointer. Let me also tell you what wild pointer is. Wild pointer is nothing. It is pretty much easy. It is like if I write int star p, so this is uninitialized pointer. This pointer is not pointing to anyone. This is known as wild pointer. Okay, and what about null pointer? It is again very simple. If you have a pointer q and if you assign null to it, then this is null. This is known as null pointer. That's it. Dangling pointer, wild pointer, null pointer. Okay, right? This is what happens. Dangling, wild, null. Got it, guys? Clear? Okay. Is this clear, all of you, or not? Please let me know. Okay, just let me know in the comment, guys. Did you understand the whole thing which we discussed right now here? This dangling pointer, uh, wild pointer, null pointer, memory leak. Okay, great then, great. So I am clearing this off. Now there is one more concept related to this dynamic memory allocation and pointers and all. That is generic pointer. This also sometimes they ask, what is generic pointer? Generic pointer is nothing that void star, which we skipped just a few moments ago, and I said I will discuss it. This void star is actually known as generic pointer. Why it is known as generic pointer? First reason is it can be converted into any kind. Converted, it can be converted into any type of pointer. Like we say, like we saw there, right? Void star I can convert it into int star. It can be converted into char star. It can be converted into float star. Any kind of other kind of pointers you can convert it. Okay, you can convert void star into any kind of pointer. That's why it's known as generic pointer. Also, the second reason is it can handle handle any kind of pointer. Okay, what I mean to say is if you have a void pointer, void star p, let's say, You can store here address of an integer also. Let's say you have x, okay, integer. So you can hold here address of x. Fine. It can handle any kind of pointer. In the same p, you can also, let's say you have a character variable ch, so you can also hold address of character variable. That is also fine. So it is able to handle any kind of pointer. It can be converted into any kind of pointer. That's why it is known as generic pointer. Sachin, wild pointer is nothing but uninitialized pointer. Like let's say int star p. So you have just created a pointer. It is not pointing to anyone. You have not stored address of any variable or something. So it's just it is wild pointer. Uninitialized pointer are known as wild pointer. Okay, right? So this is, it can be converted into any kind of pointer. We have just seen, guys, in the malloc we have typecasted it into by writing int star. Okay, right? So it can be converted into any kind of pointer. It can handle any kind of pointer. That's it. But see this, what is the problem here? When let's say I have stored address of x, now if you try to print the value, if you try to access the value by p, it will give you error, guys. Why error? See this. The reason behind this is you are saying p is a pointer to type void, but what you have stored actually, you have stored actually address of an integer. So basically, you're meaning that you want to store integer, you want to print integer value, but you have stored address in a void kind of pointer to void. So when it is trying to print the value, it is not sure what kind of value it is. Okay, is it storing integer value? Is it storing character value? Is it storing float value? Is it storing double value? Any value? It is not clear. It is not defined. There is no clear defined value here. That's the problem with void star. Of course, it can handle, like it can store address of integer, it can store address of character, it can store address of anything, guys. But while you print it, you have to typecast it. And how to typecast? Just write this, typecast p into int star, then you print its value, then it will give you the final result an integer, otherwise it will give you error. So there is no defined value, there is no defined type. P is a void star of type, you can say. P is a pointer to void, so there is no defined type of value. We cannot say what kind of value it is holding, whose address it is storing, whether it is holding address of integer or character or what, we don't know, right? So that is the problem here. So we need to typecast it. That is why we typecasted there also in malloc, in star. Okay, right? That is why we also typecasted, right? Because malloc returns void star of value, void star type. We need to convert it into int star because we are supposed to hold address of an integer in p, not void star. Got it? So this is all about generic pointer, guys. This is our generic pointer, which is void star. Yeah. Okay, so these are the four things which I had, not four, five things I had to discuss about this dynamic memory allocation and pointers, guys. Like memory leak, generic pointer, wild pointer, null pointer, tangling pointer. These five things are very much important. Normally they ask, actually. Fine. Okay, it took a lot of time, but I think that that was required. That was required, and we did a great job by discussing all those stuff. Anyway, like it took time, but yes, that was important for me to discuss so that you will get to know. Okay, so at least, guys, whatever we are doing, at least we should be clear. We should be very much clear in those parts. Okay, use of wild pointer, it's just a pointer. Okay, it's just a pointer like which is not pointing to anyone, that's it. Okay, no proper use case, right? Just ask you sometimes in the interviews what is wild pointer, just say uninitialized pointer, which is not like a pointer which is not pointing to anyone, that is wild pointer. A situation, basically. It's not a type of pointer but a situation. Yes, guys, so let's finally get into, anyway I'll complete this linked list tomorrow. but let's at least have an introduction about. Okay, so yeah, so let's have this just to have let's have a quick introduction to linked list actually. Okay, right? So what is linked list? Linked list, we know, is a collection of nodes which are linked together, right? Okay, which are linked together. This is a linked list. Linked list is nothing but a collection of nodes which are linked together, right? And they're holding some value, let's say 10, 20, 30, and 40. So if you talk about each node, so we have to take so many nodes and they are linked together. That's what is a linked list. What is a node? Single node. Let's see. Let's understand what is a node here. What it consists of. So this node, guys, consists of two parts. Okay, this consists of two parts. This node. That is, one is the data part. One is the link part. Also, we call it as next normally. So basically, this link is a pointer, guys. Okay, and data will contain data. It may be integer data, it may be character data, it may be string data, any kind of data. So any node will have two parts. One part will store data, one part will hold address. Whose address? Address of next node. That is why this. That is how the links are formed. Let's say address of this node is 101, address of this node is 201. So here 201 would be stored and we say that it is pointing to the next node. So this next or this link, basically it's a pointer which is holding address of the next node. Each node consists of two parts, guys. One is data part and one is this link part. And what is this link or next? This will hold address of the next node. That's it. This is what is a node, and we take when we take so many nodes and link them together in this way, then we say it is a linked list. Linked list of nodes linked together. Okay, that is a linked list. Okay, now how can we create this node? In order to have linked list, we need that node, right? So first of all, we have to create node. We have to create so many node and then we link them together. That's the next step. First we need to create node. Let's now understand how to create node. So guys, there is something which we need to know to create a node. To create a node, structure is used, guys. Okay, this structure, struct node, data, one member data which will store data of the node, and then there is, okay, anyway, you can write struct or you may not write struct. In C++, it is not required. You can just write node star next, let's say. So this structure is required, guys. And whenever you create object of this structure, okay, I don't have to write struct because we are doing in C++, right? So when you write node star, let's say X, node star X, what it will do, it will create a memory whose name is X. It will have two part. One is data, okay, one is data part and one is next part, which is a pointer, right? Okay, similarly, guys, when I create another pointer Y, not point, okay, my bad, just give me one moment, guys, sorry. It should be X and it should be Y, not pointer. So I've created a structure object X, right? And we have create a structure object Y. So two objects should be created. One is X, one is Y, data, and then is next, let's say two objects. Yeah, we can also use class, but I'm writing in a way that also you can use it in C or C++. Both in C and C++ you can write it. That's why I'm using this. Okay, see, if I would have used class and object, then no point of discussing pointers, because in class and object we don't use pointer. In C we don't have class and object. Okay, see this. So now the next thing. So I have created two structure objects actually. That's what I have created here up to this point. And what is this called as, guys? What is this? There's a particular name, specific name for this kind of structure. Who can say? What is this known as? This structure contains a member, okay, two members. One is an integer data, like it is storing some integer, and another member is a pointer to node. Next is a pointer to node, like self type. Next is a pointer to structure node. Next is a member of structure node, which is a pointer to structure node. Right? It's pointing to a self type. That is why this is known as self-referential structure. Right? So this is known as self-referential structure. So in order to create a linked list or in order to create a node, you need self-referential structure, guys. And you have two members. One is data part, one is the next part. It is self-referential structure. Okay, right. So now we have created two structure objects. So we have two nodes here, right? How to store some data? How to store some data? I want to store here 10. I want to store here 10 in the data part. How would I write? I cannot just write data. If I want to access data of x, I have to write x dot data equal to, let's say, 10. So 10 would be stored here. Then if I write y dot data equal to 20, so 20 will be stored here. Okay. If I write x dot next equal to null, so null would be stored here. It's a pointer, right? Now it is not pointed to anywhere. I'm making it a null pointer. Similarly, I'll write y dot next equal to null. So even here null would be stored. So I have two nodes here. I have two nodes here, and they are having their respective data 10 null and 20 null. In order to link them, I have to link them, right? How can I link? It's pretty much clear. It's pretty much easy. Just write, you store address of y in next of x. Okay, you store address of y in next of x. What is address of y? Let's say address of x is 101, address of y is 201. So basically here this null would be replaced with 201 and this will point to y. We say that the two nodes are linked together now. After this step, the nodes are linked together. So we have two nodes in this linked list, guys. Okay, right? Okay. Yeah, using dot operator is exactly. Using dot operator, we access members of a structure because you cannot access the member of a structure directly. So use dot operator. Okay, but the thing guys here is we haven't actually used dynamic memory allocation. The whole point of using linked list was to use dynamic allocation. Linked list is dynamic, but here we haven't used dynamic allocation. We have just created a structure object statically and we link them together. That is not the point. That is not the way in which we create a linked list. Okay, so when you create node, you should actually create it in a dynamic way. You should use dynamic memory allocation. So see this. So this structure is there. Find int data in data and you have this pointer, right? Node star next. So what you do guys here, you have to create pointers actually. Node star x, let's say. Okay. In order to create memory dynamically, you have to write new node. So dynamically a memory will be allocated. Obviously it will have two part, one data part and one next part. Let's say address of it is 101. So x is another pointer. That 101 would be stored in x and x is pointing to this node. That's what you should do. This is what we have to do using dynamic memory allocation. This is what we have to do, guys. Okay, because the whole point of using linked list was linked list being dynamic and we had not used dynamic memory allocation. Now we are using dynamic memory allocation. So new node will create memory dynamically and that address of that node will be stored in x. X is a pointer. Now how can I store data here? I want to store here 10 or something and null here. How can I do that? So now x is a pointer to this structure, guys. Pointer to this structure object. So I cannot use dot or dot operator. Dot is used when you have structure object directly. If If you want to access structure members through pointer, then you have to use arrow operator. X arrow data equal to 10. So 10 would be stored here. And X arrow next, if you write null, then it will store null. So this is how you access the structure members using pointer. Okay, you don't use dot here, you use arrow operator. Arrow is nothing, hyphen and a greater than symbol. That is how you use. Okay, right? Okay, so this is the same thing, like you create another node star y, new node, right? So one more new node would be created. Maybe address is 201. This is data part, this is next part, and this is, let's say, yeah, so yeah, the y would be, memory would be allocated for y. Both x and y are pointers, guys. So in y, address would be stored 201. So y is pointing to this new node. And how to link them? Now it is quite easy. So you'll write x dot next equal to, what you have to write? You have to write y, x, not dot, arrow, x arrow next equal to y. Y is a pointer, guys, and it is holding address of the new node. You don't have to write ampersand y anymore. When you write y value is 201. So that 201 would be stored here, and now this is pointing to this node. This is how you link two nodes dynamically. Dynamically allocated, dynamically created nodes, and this is how you link them together. Like this, we'll create node one by one and we'll link them together. Okay, I'm not extending this session anymore. Anyway, we have extended a bit. Okay, tomorrow we would actually uh, code it. Okay, tomorrow we'll code it. We'll understand it, how this is created actually, how exactly we create a node, how we would link them in a code. We'll understand. Okay, right? So these are the ways in which we are doing this. You understood this part? Node star x equal to new node. It will create a node, right? How to access member of a structure using pointer, using arrow operator. So when I write x arrow data equal to 10, so 10 is stored here, right? Okay. When I write x of next equal to null, so null is stored here. Okay, then I created one more node y. So a node is created, and address of that y, the new node is, sorry, not y, address of that new node 201, it's stored in y, and we say that yes, y is pointing to the new node, but both of them are null right now. Okay, both of them are the, like, we can say that this is not pointing to this anymore. It is still holding null here. It is still holding null. This is null, even this is null. How to store some data in y? How can we store? Easy, right? You write y of data equal to 20. So 20 would be stored here. And if you write y of next equal to null, so null would be stored here. This is how you access member of structure using pointers. Now, how to link them? I want to link them. This is the whole thing about linked list. I want to link these two nodes. So I have to store address of this new node in next of x. I have to store address of this node y in next of x. For that, you just have to write this, guys. In x of next, you store y. What is y? Value of y is 201. It is a pointer, right? So 201 would be stored in next of x. So 201 would be stored in next of x. That means next is now pointing to this node y. That's it. Understood now, Dharmik? Yeah, tomorrow I'll have, like, I'll go for a quick recap, and actually will implement it using code tomorrow. So it would be more clear actually tomorrow when actually I'll code it out. Anyway, like, I think I've re-explained it. Now it should not be an issue. I hope you understood now after me explaining it again. I'll post it tonight only, Digar. Okay, I'll post it tonight only. Clear, guys? Dharmik, is it clear to you now? How I created two nodes, how I stored some data in the nodes, and how then I linked them together. Okay. Jishan, there is no specific course for only DSA, Jishan. It is all like it is embedded into other courses. Like you can opt for PGP full stack Python, Python Django. You can opt for PGP full stack AIML or PGP full stack data science or PGP full stack web development. In all these four, DSA is embedded because we prepare you for the placements and interviews and all. Okay, right? Dharmik, it is clear to you now after I explained it again. Okay, fine. I will make a quick recap tomorrow about this, whatever I have discussed today, right? Okay, let's not extend any more this session. I think we have discussed a lot of things today. I think now that's why it is going bouncer to you right now. So let's stop here. Let's call it a day, guys. And tomorrow I will make a quick recap of this thing and we will code it end to end. We'll create linked list. We'll discuss about other functions like insert function, okay, display function. We'll discuss and we'll finish it off. Okay, announce. Sorry, attendance, guys. I want to make a few attendance announcement here, guys. Please do fill up attendance in the form, Google form. Okay, a link was shared, I think, few moment back, but it seems that link, due to some server issues, that is not working, and your attendance could not be recorded. So please do fill your attendance on the Google form itself. Okay, yeah. So guys, uh, Jason, that's what we follow here. You have to submit it through GitHub. Okay, right? That's what we have to follow. So thank you everyone. Thank you everyone, guys. So thank you for joining in. Thank you for bearing me for so long. Again, let's meet tomorrow at the same time. We'll cover this linked list. We'll code it. Okay, from start to end. This linked list thing. Yeah, sure, Dharmik. I'll fine. Yeah, sure. I'll do it. So, yeah, guys, let's end this session. Bye bye. Take care. Good night.